Late spring arrives, and the first paper wasp appears under the eave where last year's nest was removed. Within days, a small gray structure begins forming in the exact same location. By midsummer, the colony is active again, and another service call is scheduled. The exterminator arrives, sprays the nest, charges somewhere between $100 and $300, and leaves with a promise that the problem is handled. But the following spring, the cycle repeats. Same corner of the porch, same species, same frustration. Most homeowners assume this is simply bad luck or poor treatment, but the truth is far more specific. Wasps do not return to the same locations randomly. They are following chemical signals left behind by previous colonies, pheromone trails that persist in wood and crevices long after the nest itself has been destroyed. And because those signals are never addressed, the problem never ends. What makes this pattern even more interesting is that the solution exists, costs less than $30, and can last an entire season or longer. It does not require toxic foam canisters, recurring service contracts, or emergency calls when a nest appears near a doorway. It requires understanding three things: wasp behavior, basic chemistry, and the biological reason colonies keep rebuilding in the same spots year after year. The first key lies in how wasps find food. Social wasps, yellow jackets, paper wasps, hornets, are scavengers. They hunt protein to feed developing larvae and sugar to fuel their own flight and activity. Unlike honeybees, which communicate specific flower locations to their hive through structured waggle dances, wasps operate opportunistically. A soda can left on a picnic table, a piece of fruit fermenting in the grass, or a bait station placed intentionally near their territory will attract them immediately. Honeybees ignore these random food sources entirely because their foraging system is built around floral signals and hive communication. A container of sugar water sitting on the ground does not register as a viable food location within their behavioral framework. Wasps, by contrast, will land, drink, and carry liquid food directly back to the colony. This difference is not trivial. It is the biological foundation that makes selective baiting possible. When a wasp discovers a sugar source mixed with a slow-acting toxin, it does not die at the feeding site. It returns to the nest and shares the liquid with other workers, the queen and the larvae, through a process called trophallaxis, mouth-to-mouth food transfer that occurs constantly inside social insect colonies. Within days, the toxin circulates through the entire colony. The queen stops laying eggs. Workers weaken and die. Larvae fail to develop. And the colony collapses from the inside without any direct human intervention at the nest site itself. The material that makes this possible is not exotic, restricted, or expensive. It is a white crystalline powder that sits on hardware store shelves in the pest control aisle, usually in a small plastic container labeled boric acid. Boric acid has been used as an insecticide for more than a century, but its effectiveness depends entirely on how insects encounter it. When applied as a dry powder along baseboards or in wall voids, it works slowly as insects walk through it, and later groom the particles into their digestive systems. But when dissolved in a liquid bait that wasps actively seek out and consume, the mechanism accelerates dramatically. Boric acid is both a stomach poison and a desiccant, meaning it attacks insects through two separate pathways simultaneously. Once ingested, it disrupts the lining of the digestive tract, interfering with the insect's ability to process nutrients and maintain internal chemistry. At the same time, the compound draws moisture out of cells through osmotic pressure, gradually dehydrating the insect from within. The critical advantage of boric acid in wasp control is that it does not kill instantly. A wasp that drinks a bait solution containing boric acid will live long enough to fly back to the colony and participate in the normal food-sharing behavior that defines social insect life. That delay transforms a single poisoned wasp into a delivery system for the entire nest. The bait itself requires only two ingredients: a sugar source that mimics the carbohydrates wasps seek in nature, and the boric acid powder dissolved into that liquid. Apple juice works particularly well because it contains both sugar and trace amounts of amino acids that register as protein signals to foraging wasps. The preparation is straightforward. 2 cups of apple juice mixed with 2 teaspoons of boric acid, stirred until the powder dissolves completely into a clear solution. The mixture is then poured in small amounts into empty soda cans, with just enough liquid at the bottom that wasps can reach it without drowning. If wasps drown in the bait, they cannot return to the colony and the method fails. A small wooden stick or twig placed inside the can creates a ramp that allows wasps to land, walk down to the liquid, drink, and fly away. These bait stations are placed around the property perimeter, under eaves, near known nesting sites, along fence lines, anywhere wasps are active but pets and children cannot easily access them. Boric acid is far less toxic to mammals than to insects because of differences in metabolic processing and body size. A dog or child would need to consume multiple tablespoons of the raw powder to experience symptoms, and at the diluted concentrations used in bait solutions, the risk is minimal. Even so, placement should be deliberate and the stations should be checked periodically to ensure they remain undisturbed. Within 72 hours of discovering the bait, wasps begin carrying it back to their colonies. Within a week, activity around previously busy nests often declines noticeably as the colony's internal structure begins to fail. But bait alone does not address nests that are already established and actively defending territory near doorways, windows, or high-traffic areas. For those situations, direct treatment becomes necessary and the method depends entirely on where the nest is located. When a wasp nest is visible and accessible, and when it sits far enough from electrical wiring or fixtures, the simplest direct treatment involves nothing more than water and dish soap mixed in a spray bottle. The mechanism behind this method is not chemical warfare, but basic physics applied to insect anatomy. Wasps, like all insects, are covered by a thin, waxy layer called the epicuticle, a lipid-based coating that prevents water from penetrating the exoskeleton and keeps internal moisture from escaping. This layer is essential for survival because insects lose water rapidly through evaporation if their protective barrier is compromised. Soap, specifically the surfactants it contains, breaks down this waxy coating by disrupting the molecular bonds that hold lipids together. Once the epicuticle is breached, water floods the spiracles, the small breathing holes located along the sides of the insect's body. Wasps do not breathe through their mouths, but through these external openings connected to an internal network of tubes called tracheae. When water enters the spiracles and blocks airflow, the wasp drowns from the inside within seconds. The application requires sustained spraying directly onto the nest and the wasps themselves until activity stops completely. Partial spraying allows surviving wasps to regroup and defend the nest more aggressively, so the treatment must be thorough. But this method carries one absolute restriction that cannot be ignored. Water and electricity create a lethal combination, and every year people are injured or killed attempting to spray water-based solutions near outdoor light fixtures, electrical panels, or wiring conduits. If a wasp nest is attached to or located within a few feet of any electrical component, the soap and water method must be abandoned entirely. For those situations, professional-grade aerosol sprays designed specifically for electrical environments become necessary. Products like PT Wasp Freeze are formulated to be non-conductive up to 47,000 volts, allowing them to be used safely near breaker boxes, outdoor lighting, and other wired structures. These sprays work on contact, dropping wasps almost instantly through a combination of rapid cooling and neurotoxic compounds that paralyze the insect's nervous system. The effective range extends up to 15 feet, which allows treatment from a safer distance without requiring a ladder or close approach to an active nest. A single canister costs roughly $15 and remains effective across multiple seasons if stored properly. The choice between soap and professional spray is not a matter of preference, but of safety and context. Soap works when the nest is isolated from electrical hazards. Professional spray works when it is not. But even after a nest is destroyed and the immediate threat is eliminated, the most important step in wasp control has not yet been addressed. Because the nest itself was never the real problem is what the nest left behind. Paper wasps and yellow jackets do not choose nesting sites randomly each spring. Queens emerging from winter dormancy search for locations that previous generations have already validated as safe, sheltered, and productive. They find these locations by detecting chemical markers left behind by earlier colonies, pheromones secreted from abdominal glands as wasps build their nests. These pheromones are not volatile compounds that dissipate quickly into the air. They are lipid-based molecules that bind to wood fibers, paint, and the microscopic texture of building materials, persisting for months or even years after the original nest has been removed. To a queen wasp in early spring, these chemical traces function as a biological recommendation system. A surface marked with nest pheromones signals that this location has already supported a successful colony, which means it offers protection from weather, proximity to food sources, and relative safety from predators. The queen does not need to evaluate the site herself. The chemistry does that work for her. This is why homeowners report the same problem in the same corner of the porch, under the same eave, or inside the same shed year after year. The nest may have been knocked down in late autumn or sprayed in midsummer, but the pheromone trail remains intact, guiding the next generation back to the exact same spot. Removing the visible nest does nothing to eliminate the invisible signal, and as long as that signal persists, the cycle will continue. The solution requires treating the surface itself, not just the nest. Waterproof insecticidal dusts designed for outdoor use can be applied to eaves, rafters, soffits, and any other location where wasps have previously built. These dusts contain active ingredients that remain effective for months, even through rain, temperature fluctuations, and direct sunlight. Products like Delta Dust are formulated specifically for this purpose, combining a desiccant base with a slow-acting insecticide that adheres to any wasp that lands on a treated surface. When a queen investigates a previously marked site in early spring, she picks up microscopic particles of the dust on her legs, antennae, and body. She carries those particles back to wherever she begins constructing her new nest, and the dust interferes with her ability to complete that construction or sustain the early colony. Even if she manages to lay eggs, the workers that emerge will encounter the same contamination as they explore the area, weakening the colony before it ever becomes a visible threat. Application is simple. A handheld duster or even a clean paintbrush can work the powder into cracks, corners, and the undersides of horizontal surfaces, where wasps prefer to anchor their nests. One treatment in early spring before the first queens emerge can prevent nest establishment for the entire season. This is the step that almost no one takes, and it is the reason wasp problems feel endless. The nest is treated. The wasps are killed. But the invitation remains. When these three methods are used together, they address different phases of the wasp life cycle and different failure points in conventional control approaches. The bait stations handle colonies that are not yet visible, nests hidden in ground burrows, hollow trees, or wall voids that homeowners never see but that send foraging wasps into the yard throughout the summer. Because the bait relies on the wasp's own behavior to deliver the toxin into their colonies, it works without requiring any knowledge of where those colonies are actually located. Direct nest treatment handles the immediate problem of active nests in high-traffic areas, where waiting for bait to work would leave people vulnerable to stings. Soap and water solve this problem when the nest is away from electrical hazards, and non-conductive sprays solve it when the nest is not. Surface treatment with insecticidal dust prevents the cycle from restarting the following year by eliminating the pheromone trails that guide new queens back to proven nesting sites. Without this step, every other method becomes a temporary fix rather than a long-term solution. Together, these approaches cost roughly $30 in materials, a container of boric acid for around $6, a bottle of dish soap that most households already own, a canister of non-conductive spray for $15, and a small container of Delta Dust for approximately $8 to $10. The boric acid and dust last for multiple seasons because the quantities used in each application are small. In contrast, a single professional pest control visit typically costs between $100 and $300 depending on the region, the size of the property, and the number of nests being treated. Many companies offer seasonal contracts that include multiple visits throughout the summer, which can push annual costs well above $500. These services are not ineffective. Professional exterminators often use methods similar to the ones described here, including bait stations and residual surface treatments. But the business model of pest control depends on recurring service calls, not on teaching homeowners how to solve problems permanently with materials available at any hardware store. This is not a matter of conspiracy or deliberate deception. It is simply the structure of a service industry where long-term solutions reduce future revenue. A homeowner who learns to manage wasp problems independently stops calling for help, and a problem that can be solved once does not generate the same income as a problem that requires attention every few months. The knowledge exists within the industry. What does not exist is a strong incentive to distribute that knowledge widely outside of it. Not every wasp situation can be handled the same way, and understanding the limitations of these methods matters as much as understanding their effectiveness. Ground-nesting yellow jackets present a distinctly different challenge than paper wasps or aerial colonies. These colonies can contain thousands of individuals, and they defend their nests with extraordinary aggression when disturbed. Approaching a ground nest directly, whether with soap spray or any other contact treatment, triggers a mass defensive response that can result in dozens or even hundreds of stings within seconds. For ground nests, the bait method is the only safe approach. Bait stations placed near the entrance allow foraging workers to carry the toxin back into the colony without any direct disturbance, and the colony collapses gradually over the course of several days as the boric acid circulates through the population. Patience becomes essential in these situations, because attempting to speed up the process by interfering with the nest almost always makes the situation worse. Boric acid, while far less toxic to mammals than to insects, should still be handled with basic caution. At the concentrations used in bait solutions, the risk to pets and children is minimal, but the raw powder should be stored out of reach, and the bait stations should be placed in locations where animals cannot easily knock them over or consume large quantities of the liquid. Electrical safety remains non-negotiable. No water-based treatment should ever be applied near wiring, light fixtures, breaker panels, or any surface where electrical current is present. The consequences of ignoring this rule range from electric shock to fatal electrocution, and the risk does not diminish just because the nest seems small or the situation feels urgent. If the nest is near electricity, the only acceptable option is a non-conductive spray designed specifically for that environment. Local wasp populations also vary by region and species, and some wasps may show different levels of attraction to bait depending on what other food sources are available in the area. In agricultural regions during harvest season, for example, wasps may have abundant access to natural sugars and proteins, which can reduce their interest in bait stations. In those cases, timing the bait deployment earlier in the season, before natural food sources peak, often improves effectiveness. These limitations do not invalidate the methods, but they do require observation, adjustment, and a willingness to adapt the approach based on what actually happens rather than what is expected to happen. Every spring, when the first wasp appears under the eave where last year's nest once stood, most homeowners see the beginning of another expensive, frustrating season. What they are actually witnessing is a chemical conversation that has been unfolding for millions of years, a biological system in which pheromones guide queens back to locations their species has already tested and validated. The nest was removed, but the signal was not. And because that signal remains invisible to human perception, the cycle repeats endlessly unless someone understands what is actually happening beneath the surface. The tools to interrupt that cycle do not require professional certification, specialized equipment, or ongoing service contracts. They require a basic understanding of insect behavior, a few dollars worth of materials that sit on hardware store shelves year-round, and the willingness to treat the problem at its biological root rather than its visible symptom. A container of boric acid dissolved in apple juice addresses colonies that cannot be seen. A bottle of soap mixed with water addresses nests that can. A non-conductive spray addresses situations where electrical safety matters more than cost. And a layer of insecticidal dust applied to surfaces in early spring ensures that the pheromone trails guiding next year's queens lead nowhere. The knowledge was never hidden in the sense of being deliberately concealed. It simply existed outside the commercial framework that most people encounter when they search for solutions to household pest problems. Service-based industries are not built to teach customers how to eliminate the need for future services, and the economic structure of pest control reflects that reality without requiring any conspiracy or intentional suppression. The chemistry works, the biology is consistent, the methods have been used professionally for decades. What remained obscure was not the science, but the accessibility of that science to people who assumed the problem required expert intervention. The wasp, returning to the same corner of the porch, is not looking for a fight. It is following a trail left behind by a colony that no longer exists, reading a message written in molecules that persist long after the structure that created them has been destroyed. Understanding that message and knowing how to erase it is the difference between spending hundreds of dollars every season and spending $30 once.